Hey, this is Coach Miko. Today we're going to get into a little bit of our first topic here. It covers both Algebra 1 and Algebra 2, kind of combining the first three sections. You'll see here it's just an intro to algebra. And we're starting out with the essential question, how do we think logically to solve problems in everyday life? Okay, so we do this stuff all the time. I talked about it already in class. When you go to the store and you try to figure out if you have enough money to buy the different things that you want to buy, you're doing an algebra problem in your head without the big equation or anything, but you're still doing an algebra problem. The first thing we want to look at is what's an algebraic expression. Okay, an algebraic expression is a mathematical phrase describing a real-world problem. Okay, for example, 32 more than a number n can be written as 32 plus n or n plus 32, because order of operation doesn't matter in addition or multiplication for that matter. Okay, so the difference between an expression and an equation is the equation will be equal to something. The expression is just that, it's an expression, and I'll show you here in a later example how we evaluate that. Some terms that help you determine which operation you want to use. What operation? Well, if in your problem there's words like more than, add, sum, well then we should recognize that that's an addition problem, so we're going to add some terms together. If we get less than or a difference, that means we're going to subtract. If you get times or product of two things, that's to multiply. Or if you see the word of, that means to multiply. And if you get a quotient, that's an answer to a division problem. So we're looking for words like that in our problem if it's written out, like you'll see in another example, of how to come up with that equation. If they just give us the expression, we can just go from there. How do we evaluate an expression? Well, first thing you always want to remember is your order of operation. Please excuse my dear Aunt Sally. We do parentheses first, then if there's any exponents in the problem, we do that. Then we multiply and divide, and you do that left to right just like you read. And then same with addition and subtraction at the end. So you solve those sequentially as you work through your problem. Just don't start left to right and start add, subtracting, multiplying, dividing. You look for those properties first. The second thing is substitute the number in for the variable and then just solve it by using your order of operation. So for an example, if you had evaluate x times y quantity squared when x is 5 and y is 2, then first off substitute in your numbers for your letters, for your variables, and then order of operation. Do what's inside the parentheses first, 5 times 2, and then square it. So 10 squared, we know is 10 times 10, so your answer is 100. So that's how we evaluate that problem. Your problem also could come in the form of a mathematical sentence or word problem. 2/5 of wages go to savings. 2/5 of your wages. We said earlier that of means to multiply. So that's how we're going to set up our problem. And then it says if you're making $40, how much goes towards your savings? Well, 2/3 of our wages, I gave the variable W to represent our wages, so 2/5 times W will equal S, and that's just a script S that I have there. That'll be your savings. So when we substitute in our wage for that week is $40, 2/5 times 40. Remember when you're multiplying fractions, you can write 40 as 40 over 1, and then it'll just be 2 times 40, you multiply across the top, and then 5 times 1, you multiply across the bottom. We get 80 over 50, which simplifies to $16. So 2/5 of $40 is $16, and that's what's going to your savings. Okay? So that's how we evaluate expressions. Technical difficulties, we'll work through them. How do we classify real numbers? That double bar R that you see right here, that means real numbers. Okay, and I'll use that abbreviation quite a bit if I'm using the word real numbers. We start off with real numbers. That's all numbers that we use. Okay? We break those down into rational and irrational. A rational number is any number you can write as a fraction. Whether it's 2 and you write it 2 over 1, or it's 5/3, it's a fraction. Irrational numbers are those numbers that you can't write as a fraction, like pi. That's one you've used quite a bit. We know it's 3.14, but the number actually just goes on, and the decimal never repeats. It never terminates. The square root of 2, the square root of 3, numbers like that, it's the same thing. They're all irrational. You can't write them as a fraction. We can approximate it, estimate it, but it's not precise. So now we look at our rational numbers. We break the rational numbers down into integers, and that's like -3, -2, -1, 0, 1, 2, 3, and it goes infinity both ways. There's no fractions. It's just those numbers, okay? No fractional or decimal parts. Whole numbers is just the positive, 0, 1, 2, 3, 4, 5. No fractional parts. The natural numbers start with 1, 1, 2, 3, 4, 5, just like the counting numbers. Again, there's no fractions in those. If you throw a fraction in with it, 1 1/2, -2 1/3, they're just rational. They're not integers or whole numbers. Properties. I want to touch on properties. The biggest property that you'll see and that we use the most is the distributive property. A times the quantity B plus C equals A times B plus A times C. That we use a lot, okay? That should look familiar to you. The others, you'll see them, but we don't use them a whole lot. The commutative property, I listed here, it's just A plus B equals B plus C. For the commutative property, we just change the order. And you can do that in addition and multiplication. We're aware of that. We do that. That's the reason why we can do it, because of the commutative property. You can't do that with subtraction and division, which we already know. Associative property, when you see parentheses involved and you just change the grouping, like here the quantity A plus B plus C equals A plus the quantity B plus C. We regrouped. That's the associative property. The identity property, where you add 0 or multiply by 1, you don't change the value. That's the identity. You don't change the identity of your number. And then the last one is zero property, and that's when you multiply by 0 and you get 0 for an answer. That's the zero property. Okay? So make sure you get these notes down. They're in Cornell form. If you have any questions, just denote it on the side somewhere, put an asterisk next to it, highlight it, whatever it is. When you come in class tomorrow, we'll go over it, we'll summarize what we did there, and then I've got some problems for you to work on in class to reinforce these concepts. All right. Thanks a lot. See you tomorrow.